Hello everyone, for First Updates Now, I'm Tyler Olds, and you're watching Behind the Bumpers. It's a fun show where we dive deep into the FRC robots and what makes them work. And today I'm here with team number 4499, the Highlanders from Fort Collins, Colorado. And this team is really living up to their rookie all-star year in 2013, including 2 Engineering Inspiration Awards, 3 Chairman's Awards, a 2018 division winner and world finalists, and then also won the Greater Kansas City Regional last year. And I'm here with Cooper, Jack, and Adarsh, and we're going to be diving more into their 2020 robot, what their plans are for their 2021 robot, and what makes this all work here on Behind the Bumpers.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker is a leading medical device company and is looking for those in FIRST to join their team as interns or for a great career. Come join a company that will actively support you being in FIRST at careers.stryker.com. If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com, and let's get your team scheduled to be on First Updates Now. So Cooper, this is your 2020 robot here, and I know we'll be talking about some of the changes to make on the 2021 robot as we go through, but we really want to highlight this incredible machine. As mentioned, you guys won the Greater Kansas City Regional last year, and take us through starting with the power cell. I want to hear about the intake, what you have, the magazine, and going through some of the design process on it. And I know Adarsh is going to be talking about some of the programming as well, so let's hear about it.
Yeah, so the thing about our magazine design is we wanted to make sure that we're able to pick up the ball pretty much anywhere along this edge of the robot. So if we go ahead and put it on the side right there, you see that it's able to pick it up on there. If you put a ball on that side, you see it's able to pick it up on there. And that's because of vectored mechanism wheels that we use that actually just go ahead and funnel it toward the center. And as soon as the ball actually hits, there's actually a beam brake sensor hidden within the tube right here that lets us detect the ball, so that way the programmers know and can actually change their code based on how the ball is positioned in the magazine. Darth, want to be more detailed on that? Yeah, so basically we have 3 beam brake sensors, one right at the start next to the intake, one right before the shooter, and then one halfway through the magazine. So basically these 3 beam brake sensors help us know exactly how many balls we have and where those balls are in our magazine. And what we can do in code is when the beam brake replies that there's a ball in between it, then we can basically say, let's move the ball through so that we have all 5 balls get through without jamming.
So tell me about some of the iterations that you've had on this robot here. So I'm going to infer that it didn't work exactly right the first time, right? So can you tell me about some of the processes on the intake and then into the magazine as well? Like, what did you start with? What was some of your brainstorming thoughts? And then how did that lead into what you have today?
Yeah, so we can start off with the intake, actually. The intake mechanism used to not be a sort of separate piece. There used to be a huge arm mechanism out here that would actually include our climber and intake, but at the same time.
Sure.
It still utilized the same it still utilized the same mechanism vector math that we used here, but it was definitely a lot more inconsistent, so we ended up going with this new design. As far as the actual internal magazine is concerned, we ended up having to add a lot more motors in there for individual control of the balls than we wanted, which is actually why we changed it up on our 2021 design. Show later.
Yeah, and we'll definitely be talking about that a little bit later as we go through. So let's kind of keep following that journey as we go. I know we're going to be talking about the shooter here a little bit. A lot of packaging in this robot. So I think Jack's going to be covering the shooter and climber, and then a little bit on the 2021 robot as well, too.
All right. So the shooter, after the power cells get funneled into the shooter through the magazine, they hit this indexer wheel, which won't allow them to pass until we are ready to shoot, at which point the flywheel will spin up using 2 falcons that are at half speed geared up to full speed, so that way we get that maximum torque. And we use 2 steel flywheels on the side of these rubber ones to increase our rotational inertia, allowing us to not have to spin up as much between shots. It then hits this adjustable hood, which is a bracket pinion on rails that powered by a Neo 550, allowing us to adjust our shooting angle.
How heavy are those steel weights that you have in there?
So they have, these are about 1 pound, and I believe 85% of the mass is located on the outside radius.
Sure. And then this might be a question for Adarsh as you hand it off to him, but I'd love to hear more about the adjustable positions that you're using. Do you have a certain amount of set ones you do? Because in a racket pinning, you can essentially get infinite amount of positions, right? So how many set positions do you have? And can you kind of tell us about where you're shooting from with those set positions?
Yeah, definitely. So right now, even though it's our 2020 robot, we've been using him for the at-home interstellar accuracy challenge. So that one has like 4 different zones. So what we do is we have one set point for each zone, and from there we can decide our hood position or our shooter RPM. Um, we can also shoot from anywhere on the field, but to do that, what we would do is basically determine the distance from the target to our robot, and based on that, create a function that decides the hood position and the shooter RPM.
So you said you can shoot from anywhere on the field. So you can do full court shots, is what you're saying?
We can go from around 3 to 4 feet to around 25 feet.
Sure. Okay. I just wanted to clarify. I'm like, wow, that gets to start to be pretty crazy. But in regards to the infinite recharge at home challenges, you could pretty much shoot from anywhere then, right?
Yes.
Um, can you tell me a little bit about some of the iterations on the shooter itself? I know you said you're using it for the 2021 challenge as well too. What changes throughout the 2020 season into 2021 were maybe made either from mechanical or from a programming side? There's a lot of tweaking that goes into doing something like that, I'm sure.
Yeah, since we're changing so much on our new shooter for our 2021 robot, mostly just the wheel diameter surprisingly changes a lot of those things, and
Yeah.
we're even trying to build in a new camera system to that. So I think a lot is actually going to change on mechanical and programming to the point where it's kind of up in the air at this point. But we know that we'll be able to pretty much just take longer shots, and we're even getting new lidars to account for that are more accurate.
Yeah. So let's keep moving on. I know once again, 2021, we're not using climbers, but we're still focusing on 2020 robots here on fun. And I'd love to know a little bit more about your climber and what makes it work and the effectiveness of it.
Yeah, our climber's actually a pretty interesting design. Jack is like the main man who sort of worked on that, so I'll go ahead and hand it over to him.
Yeah, so our climber is actually split up into 2 positions. So we have the pole here, which actually extends the climber up. All right, so we'll extend the climber up. So the pole here is the part that actually puts the hook on, and so we can go ahead and raise it up using a pulley here. And this can go to 3 inches below the maximum position on the lever if it is tilted all the way. And if we go ahead and drive it over to this hook, so it'll latch on and disconnect the pole from the hook, in which it will then be engaged by this winch mechanism, which is powered by a Falcon and a custom gearbox. And it actually has a custom ratchet we designed. You can see it right there, where it engages all the time using spring, unless we actually pull it back with the piston if we want to go down.
Makes sense. So a question I ask teams that tend to use a hook and winch on that is that from a design choice, you're kind of one and done in many circumstances, right? Like I know with your bot, it looks like you can get in position pretty well, but how do you kind of do that cost analysis where you're like, hey, if we miss and we start pulling or something like that, then it's not going to work anymore. So what makes you choose to still go that route or that system?
So we originally had a fixed system where the hook was attached to the pole that brought it up, but we changed that design so that way we have a lighter system here and have the winch there. And so our plan was to use a system of O-rings that actually, unless we put a decent amount of force into the pole, will not pull off the hook.
Oh,
So you
sure.
can see the O-ring right there.
Oh, that's really cool.
And
I love having that design feature into that. It definitely makes it work well. I mean, because the winch, when it hooks, you're guaranteed every time, right? Like it's always going to go well for you. So really cool to see that you put a little bit more thought process into that. So so we talked a lot about the 2020 robot, and you're using 2020 robot for the at-home challenges as well too. But I know you have some ideas on what you want to do for a 2021 robot, and you have some CAD that you want to show, and you've already started on your chassis as well. So walk us through that a little bit.
so if we come over here to the CAD, you can see, so the magazine actually has changed quite a bit from the original 2 belts on the sides. Instead, we are powering 24 individual rollers throughout the top and bottom, as well as the arc across the back of the magazine.
So what made you decide to go with that route instead?
So one problem we ran into is it would get powered to the side, but when we were intaking 2 balls, if they got stuck on the top and bottom, they would jam, and we wouldn't would disable us for the rest of the round.
Sure, that makes sense. Anything else from that you're looking at changing that you can show off in CAD?
So the next main thing we changed would be we did slight changes to the intake design to reduce any dead zones where the balls would get stuck, as well as our intake now has a adjustable height mechanism. You can see here where if our intake is ever at the wrong height in the middle of a tournament, we could just tighten or loosen those bolts, which would change the height of the intake. So our timeline, we're hoping to finish our 2021 robot by the middle of April. And you can see our chassis here. We actually begun remanufacturing the entire robot. And so this is just the chassis, as well as we have a gearbox here that would it is not quite greased up yet, but it will slot in right like that.
So I want to go over to Darsh, who's going to be talking about a little bit more about the programming, the pathing on the robot, and a little bit more that goes into that aspect of the robot too. It's always interesting to hear and even more see what you have to show for something like that.
Yeah, so I'll hand you on over to Darsh, and we can get the vision go. Like we can show you the programming behind the vision as well as the pathing.
Sure.
Our camera wire is underneath our robot. So down here, we just have our camera wire. And once I plug this into a computer, we can actually see what the camera is going to be seeing. So what we're going to be seeing now from the camera is our camera system basically tracks the reflective vision tape that is on the target.
Sure.
And we flash a really, really bright green LED light ring at that target. And essentially, the camera tracks that using OpenCV and Python using a hop lines function. And the camera will return distance and angle to the target so that the robot can auto align. So what we just saw is the light ring turned on in our camera, and essentially the camera saw the green that's reflected by the reflective tape and tracked it in the frame. So you might notice that our camera, or the vision target, was actually flipped sideways. The reason we did that is because our camera has a higher horizontal field of view. So we just wanted to be able to make sure that we could see the target from both like 3 feet away to 30 feet away.
Very cool. Anything else on programming you want to overview at all on this robot?
We can show you a firing sequence as well as some pathing for the at-home challenges.
Yeah, let's take a look.
So if you just want to come over here, we can actually see the camera right here. It's mounted sideways to extend our range. And at the front, we have our light ring.
So question for you on something like this is that, obviously there's the Limelight that's available to many teams, and many teams have used this. How does this either differ from the Limelight, or if it's not too different, why did you choose to go with a custom option versus the Limelight?
Definitely. That's a really great question. The Limelight is $300 or $400, I believe.
Yeah.
The camera that we use, the Jawa camera, is only $50, and it has a lot of options to customize it. And we just found that the Jawa is a really simple solution. It had some great tutorials to learn it. And it was a pretty cheap solution as well compared to the $400 Limelight.
Yeah.
So we use that, and it's been pretty consistent for us. So we can actually show you our firing sequence.
Sure.
We can intake some balls right here. So we're going to drive up, and then we're going to hit the button to shoot. And we can shoot from different zones. This is around 10 feet away. If we can grab that ball and then back up to here. And we can shoot from a farther distance as well, using a different hood position and shooter RPM.
Sure.
So we're going to be running the bounce path now. That's basically going to go through these cones, tap the cone, and then end up in the end zone around here.
I think this will be the first time we've seen this challenge on a Behind the Bumper, so really cool to be able to see a couple different ones on here.
So that path was completely autonomous.
So we also have Jillian here from 4499, and they've actually created a book as well, too, they're going to be talking a little bit about. So tell us a little bit about this book here.
So we have our Rocky the Robot series. This is book 1. We have books 1 through 4 that are on Amazon right now, and there are audiobook versions on our website and on YouTube, and we're in the process of making our Rocky the Robot book 5. So Amazon, Rocky the Robot.
Well, $44.99, thank you so much for taking the time to tell us about your robot, the modifications you're looking at making, both on your 2020 and 2021 bot. Obviously, as a team, you've had some great success, and we can't wait to see what you bring into the future as well, too. Good luck in this season and future ones as well.
Thank you for having us.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.